All right, so we're starting chapter 2 today. And again, most of you had already looked over the chapter and already did the exercise with the chapter. So hopefully pretty easy. Okay, so it's where we really get started here. Okay, so we're going to take a look again. We already talked about this with the comments. Hopefully that's making sense. You can do the single line comments with the 2 slashes. You can do multi-line comments where you do slash, asterisk, anything that you type after that point until you do asterisk slash will be a comment. So if you're going to do, your name and your date and everything at the top of your program, multi-line comment might be a little easier. So you don't have to do slash slash on every line. You're going to want to put that preprocessor on every program because that's our basic IO stream. That allows you to use the code in that file, which allows you to do input and output. So we're going to want that. I like to put the namespace one because then you don't have to put that on every line when you're doing cout, so it makes it a little easier. All your programs, in order to run them, they're going to have a main function. So we're going to have that main, and then we're always going to return 0. So you're going to see that return 0 inside the main. And then for now, we're just doing some basic cout statements inside there and adding some variables, which we'll talk about in just a bit. So everybody okay so far? Okay. So just kind of review again, comment. It doesn't have the multi-line comment on there. But whenever you do quotes, that means that you're talking about a string. So string is text. So if you want to display something in output, you put double quotes around it. We do our preprocessor with a pound sign. And then the file name with a greater than, less than sign. Okay, and every time we have the end of a statement, we put a semicolon. Okay. So we did this. We talked about this when we talked about chapter 1. So just a very basic printout statement. Now, if you do something like this, what it's going to do is actually going to push both of those together. And so even though you have hello there, and you have little arrows in between, it doesn't really do anything. It just, you do have a space after the word hello, so there will be a space between hello and there. If you don't put the little space inside quotes, you'll notice that there's no space in your output. So every time you hit spacebar in your actual quotes, that actually registers in your output. So if you wanted 2 spaces, you can hit spacebar twice. So the main, good question. So you always have to have that main in there. So most languages have some way to kick it off. Okay, so Java has a main, C++ has a main. Whenever you run the program, it knows to look for that particular function, and it does whatever in there. Now, we haven't talked about writing other functions yet, which we will talk about in the future. We'll write our own functions. Basically, you'll start splitting your code eventually into different, what we call functions based on what you're trying to achieve. So like if you had a calculation, you could put the calculation in a separate function, and you can put the output in a separate function and the input in a separate function. And then you can tell it to go to those different places and do that. Or for right now, we put everything in main, but that's our kicking off point. That's what, when you run your program, it knows to go there. If you call it something different, you don't call it main, it won't know to run it, and it won't run your program. So you can't change the name of it. C++ knows that it's supposed to go there. That's the starting point. And anything that's in there is what it's supposed to do. Now, if you need it to go somewhere else, like another function, you need to tell it to do that from main, and that's how it gets there. But we haven't talked about how to write other functions yet. So right now we only have the one function, and that's main, but that's the one that happens automatically when we run our program. Okay, now the cout statement you could write just like the bottom one where you have hello there. Now you could just write it as, you don't need the arrows or to write it as 2 separate couts because actually you're not putting any blank lines or anything in there anyways. But if you don't put like n line at the end, or you don't put the \n, then you don't get a new line, even if you do separate couts. So if you do a cout hello and a cout there, but you don't have an n line on the end of your cout, or you don't have a \n, it still ends up on the same line. Okay, so just to kind of review that. All right. Same thing, that's 1 line of output. But if you do it like that and you put end al, that stands for end line, then that will end up on a separate line. So programming is, and then fun will be on a separate line. Everybody with me? You can also just put a /n. Whenever you use /n, it has to go inside the quotes. So the /n would go in the quotes right after the S and is, and then you could put the word fun right after that, and it would all, be on separate lines. It would have programming is and fun on a separate line. Yes.
So remind me again what the C of the less than sign for.
That's just C++ way of printing output. So C out is output, and then we'll talk about C in as input. That's just the command for doing output, like a basic output stream. But normally you use the arrows again and put another string or variable when you're going to have input or something and you want to print out a variable. You can put the arrows and then put the variable name. We'll see that in just a bit. But there's multiple ways to do it. You could have used the /n. You didn't have to use the and L if you didn't want to. So it would look like that. Okay, so that's not a 1. I know sometimes that happens. You get an error, that's an L. Okay, and then this is what we were talking about before. So instead of doing n lines, so here we had the end L on it at the end, and then here we have the /n. You have to make sure you use the right slash, because if you put the other slash, it'll actually show that in your output, and then you'll know you use the wrong slash, because there's a / and a \. So if you use the wrong slash, it'll show up in your output. If you ever see it in your output, you can say wrong slash and just go fix it. You also can't put a space after the slash, like you can't do /n. It has to be right next to each other. Now, I will caution you that if you put a space before the \, it will actually put a space in your output. If you put a space after the n, it will actually put a space in your output. So some people don't like how it's like jammed up against the S. You could put a space there because it's the end anyways. It's going to go to the next line. But just be cautioned that when you hit space bar inside your quotes, you are putting spaces in your output. So if you don't want extra spaces, like for example, if you were to put an extra space after the /n, you'll get a space in the fun, and then that might look strange on the next line. So, all right, so that does the same thing as before. Okay, so we put the include directive up there, and the reason why is because we want to include this file, the contents of this file, so that we can do input and output. And variables, you all heard of variables in math, right? You've probably been seeing them for quite some time. They may or may not be your favorite, but we use variables in programming a lot. Everything depends on variables. So if variables don't make sense, please get help right away, because if variables don't make sense, then arrays, conditionals, loops, none of that will make sense either. Okay, so we need to make sure that this really is our foundation and we understand it. Okay, so a variable is just a way to store something. So, you put things in containers, right? And you get them out later. Just think of that like, I have this value, I want to put it in a container, and I want to take it out later. So now what you're going to do is you're going to label that container with a name so that Java knows which container to go get you, which, what are you trying to pull? Which value should I pull you back? So we give our variables names, and we try to give them meaningful names. So like if we're talking about rate, we call it rate. We don't call it X normally, because then when someone looks at your code and they see X, like, I have no idea what this is, right? So try not to be confusing. If you want to abbreviate it, call it R for rate instead of X, okay? So try to make it as meaningful as possible. Now, also, we don't want to give our variable names sentence long names, okay? Like, don't call it, this is my rate variable, because every time you use that, you have to type that in, right? That's annoying. Okay, you could, but it's annoying. Okay. We also can't use spaces in our names. When we're writing our variables, you can't use space. So if you don't like pushing all your words together, you can use the underscore between your words, and that's fine. You can't use the hyphen, but you can use the underscore. What a lot of people do is they actually use what they call camelback casing. So when you push your words together so that you can see the difference between one word and another word, you actually capitalize the first letter of the second word and the first letter of the third word. So you can tell the difference between the variables. So I would say normally you don't have names of variables that are more than like 3 words. Sometimes you'll have like 3 words, usually 1 or 2 words is sufficient. We ever hear that principle, keep it short, right? Okay. Short and sweet and to the point, right? But not so much that we don't know what we're talking about. Okay, so we pick a name like this one, the name is item, And then we pick a data type, and there's many different data types. For example, int is a whole number data type, okay? It means you're not gonna have decimals. Okay, so there's a lot of data types we have to learn. Okay, so we call this a variable definition. We're basically letting the program know that we're going to have a variable named item, and the data type that the value that we're going to store in there is going to be a whole number. So the data type is int, and that lets the program know how much space do I need to set aside? What size container do I need? What am I going to be working with? Is this going to be something that can be used in an equation later? So if you actually create a string variable, for example, and you put, you know, a number in there, that can't be used in an equation. So strings can't be used in equations. So even though they can hold numbers, you can put a number inside quotes and have it in a string. You can't do any type of arithmetic with that. You have to have it be a number type, like an int or double or something like that, to have it work in an equation. Okay, so this one you can see is number, and you can see that you do int number, and then you can do number equals 5, or you can actually do it all at once. You can say int number equals 5 and put a semicolon at the end. You don't have to do it as 2 separate lines. So the first part is the variable definition. That's telling C++, hey, I have this variable that's data type int, and the name of it's going to be number. Then initializing it is giving it a value. So you initialize it, you give it a value, say, hey, the value is going to be 5. So whenever I say number, you're going to pull up the value 5. So when you do the cout statement, the value and number is, that's going to print, and then it's actually going to print whatever values in there, which is 5, right? So there's a reason why we don't have quotes around number. If we had quotes around number, what do you think would show? No, number, good. Because quotes means you want to display it just like that. Okay, so if you put quotes around it, that means it's text, and just display it. If you don't put quotes, then C++ goes looking for that variable, and when it finds it, it gives you the value. Now, if it can't find it, like if you misspell the word number by accident, and it can't find that, you'll get an error. It'll say it can't find number, right? So you have to make sure you spell it all correctly. Spell the same. Okay, so anytime you give a value to something, that's called a literal. So when we give a string a value, like we say string name equals Bill. Bill is the literal, okay? Int number equals 5. 5 is the literal. Bool,
Like that.
Anything like a Boolean variable, class today, false or true, you know, that the false and true are literals, right? Okay, so does that make sense to everybody? Okay, so there's a literal. Apples 20 is an integer literal. A string literal is going to be the text that you have that you're actually displaying. All right, so we have these identifiers, these keywords, this big long list. Basically, a keyword, these identifiers, mean something in the C++ language. So if you can't name your variables these names, because then C++ is confused. So you can't say like int, you wouldn't even want to call anything this, something that even looks like you would. This, you can't say this because it means something. You can't say like your variable name can't be this because that's confusing. Okay. So don't use these for your variable names. They're keywords, so they mean something. Okay, an example of a variable name that has 2 words, you can see how it uses camelback casing so that the second word has a capital letter. But typically the first word is all lowercase, and then the second word is where it gets the capital as the first letter.
Could you capitalize both? Or
You can, it'll work, but
the most
preferably, yeah, you don't. Okay. And then you don't put spaces. You could put an underscore between those. If you put an underscore, it's not necessary to capitalize the O in ordered. If you want to, it's fine. It's really just preference. Because the only reason for capitalizing that second word first letter is so you can see the difference between the words. And if you put an underscore, you can see the difference. So you don't really need to. So it's completely up to you. Okay, you can use underscore, but you can't use other characters like you know, hyphens and @ symbols and things like that in your name. You can't start with a number. You can write out the number, like if you wanted the number 1, write it out O-N-E, but you can't start with an actual digit. You can put a digit in your name, it just can't be the first character. Okay. So if we look at this, you can see the first one is valid. It's kind of strange to get used to it. The second one's fine too. Again, capitalizing that S on sales, you don't have to. It's completely up to you. You cannot have a period, so the third one's not good. You cannot begin with a digit, so the fourth one's no good. And you cannot have the dollar sign, so the fifth one's no good. Does that make sense? Okay, perfect. Everybody on Zoom okay? Okay, just let me know if you're stuck or have a question. All right, so we have a lot of things here, a lot of different data types to look at. Basically, the main one we're going to use is int. Okay, int is the whole numbers. We have a lot of other ones. We're never going to have like a long in here because we don't have numbers that big in this class. Okay, but you should know that data type exists. So there are longs. If you don't want negative numbers, there are unsigned ints. And so you can just look at the range. For different ranges, you'd use different data types. Now, most of the time for what we're doing, int is perfect. I mean, we don't normally always need it, but that's the most common one to use. People usually just stick with int, unless you're really trying to save space. If someone tells you spaces, we must save every little piece of space that we can. Okay, then we need to really go back and look, okay, what can we use? How can we do this? But otherwise, really, int is most common. Okay. So you can see some different examples. You do have like, there's an example with an unsigned area variable, unsigned int area. That just means it can't be negative. So if you do unsigned, it can't be negative number. It's good for preventing negatives if you want to do that, if you know it can't be a negative. So if you want to do more than one variable, you can do them on the same line too. You just say, for example, int length, and you can just put comma with, that means they're both ints. If you had different data types, you could put comma and put the second data type on there if you had a different data type. Okay, everybody okay so far? Okay. All right, so here's just an example of a program. We have some variables at the top, some declarations, and then we have the initialization on line 11 through 13, where we actually put values in them. Again, you could do it all at once up at the top. You could just put equals and put the values in when you actually declare the variables. That's typically what I do, but your book is showing you in 2 separate steps how to do that. And you can always change the variables again later as well. And then it just prints it off. We've made a long journey of, and then it prints your miles variable, which in this case is 4,276. Our checking account balance is, and then it's going to print the checking. So do you see how to do the variables where you actually don't put quotes around the variables and you put the arrows again so that you can put the variables in there? Everybody okay? Okay. So again, you can condense it and just put the value right into the variable. And we already talked about this. I'm not sure why we have this again, but this is the same thing we just looked at. Okay. So if you're going to have a long, you put an L at the end to force it to be a long, because actually all the numbers that are whole numbers are automatically integers. So if you want to force something to be something other than an integer, you can put like long at the end to have it be a long instead, and then save it as a long data type. Again, we're not going to have numbers this big, so we won't have longs in here, but it's good to know. You can have a char, a character data type. The char can only have one character. Okay, every time you have more than one character, then that's called a string, right? So you have to be careful, because even if you have a number that's actually 2 digits, like if you have someone enter their age, once they get to 10, then that's 2 digits. So it only works up to 9. You can't do 10 because that's 2 numbers, right? So char only holds 1 character. So you wouldn't want to use char if you're working with digits, because as soon as you get more than 1 digit, it wouldn't work anymore. So char is good. Sometimes you can do something simple like, would you like to continue, enter Y for yes and N for no, and then that would be a char, and you can do a simple comparison with the char Y or N to see if the program should continue. But you use single quotes around chars instead of double is actually string, okay? So the literals get single quotes around them, and some people did that as an example for the discussion board. So that was good. You can see some of the, it's good to look at those if you want to go through those, especially if you're having trouble with variables. There's so many different examples, good examples, by the way. that people had. So you can go through and see, all the different types. Okay, so just an example of how to do chars. So you have a letter. At first, the letter is initialized at A, and then it prints off, and you can see the output down at the bottom is A. And then it's initialized at B, and the value is changed to B, and it prints off B. Okay. So whenever you're doing a string, they're actually saving different index values for each of the letters, and we'll talk about how to move through those letters later in the course. We need to kind of talk about, well, arrays work the same way and everything. We'll talk about the different index values because it's a little confusing and how you move through each one. So strings are a little more complicated because you have multiple values, but you can just think of each value is getting saved in a different index location and talk about how to access that later. But at the end, there's a null terminator to know that you're done with your string. Okay. So you can have strings. We talked about this. So if you have people's names, you might want to have like their first name and then their last name is a separate string. So you can have it separate. So you can see how to print it off. Is everybody okay with that? Okay. Then you can see, like if you had a movie title, for example, and then you wanted to print off the movie title, just remember that strings get double quotes around them. It works the same way as your other variables, just a little more complex, but just put double quotes around it for whatever you want to save inside a string. Okay, whenever we're talking about decimal numbers, we talked about whole numbers. We talk about decimals. We can have different types. We can have float, double, or long double, depending on how much precision we need. Okay. Automatically defaults to double, and that's typically what we use. If you want to save space, then people go with float if you don't need as much precision. I always say if you're working with monetary, you want to go with more precision, right? Because people care about their money. They want it to be more precise. But sometimes if you're just calculating Celsius and Fahrenheit, you might just use float instead of using double. But just think if the precision really matters, how important is it? And so you can see the different, how much space it takes up. And for long double, it depends on your compiler, how it will actually handle it. But a float is half the size of a double. So if space was really important in the program, then you don't need that much precision, you might want to go with float to save space. Okay. So, but just basically how much precision do you need? Floats are a little bit more difficult to work with. So that's why, people don't always use those. Whenever you are working with an equation and you put a number in there that's a decimal number, you have to put a little f in there to make sure that it stays a float. It doesn't get into a double, because once it gets into a double, the whole thing becomes a double. So it makes it a little more challenging. And then you can just see, this is just another example of how to use float and double. Boolean is abbreviated bool, and it just means true or false. So we use that a lot for decision making when we get to something called conditionals to decide if something's true or not true, whether we should do something in the case that it's true. What do we want to do in the case that it's false? We use bool a lot for that. So you can see like, okay, it's all done true, okay, or finished false. So it's either 1 or 0. It's either true or false. You can see same thing. They're just printing off the values of the Boolean variables. Everybody okay? Okay. If you want to know the size of whatever you're working with, you can use size of. So if you say size of, you can figure out how big the variable is by using that. I think we kind of already talked about that. So you just put the literal into the variable, and that's called the assignment. So it's called the assignment operator. Whenever we get to conditionals, instead of using like x equals 5, for example, we actually use x equal 5 because of the equals is used for assignment. Like it means make this equal to this. So whenever we check things to see if they're equal, we'll start using equal. But 1 equals means to make it something, to assign the value to that particular variable. Okay, we can't write it the reverse way. So I know it's kind of weird to start with a variable and then put equals and then put your equation after it, but we can't switch it up like that. C++ won't let us do that. And then you can kind of condense if you want to, you know, if you're trying to define multiple variables. If they're all integers, you can put them all on one line like this. And then just an example, same thing, the month 2 and days is 28. They're both integers, so you can combine them on one line and then just print them off the same way. So you can really make your cout statements as long as you need to print off whatever it is you're talking about. So it prints the month and then the month value and then has and how many days. Make sure that when you're doing it, when you test your output, you have good spacing, which means you put spacebar in the right places. Like before you have a variable, normally you'll have a space in your string so that your value from your variable doesn't push right up against whatever your string was that you were having. So you wouldn't want it to say month 2 and have the 2 right up against the H. So you can see there's a space after the H right inside quotes. So you always want to make sure that your letters and your digits and everything aren't pressed up against each other and you actually looks nice in your output. So it might take some time to get used to that, but hopefully not too bad. Okay, this is a pretty cool feature in C++ 11 that you can use auto, which means that you don't have to put the variable type. You can actually just say auto and C++ will figure out what type it is. So it's kind of cool. If you want to do that, that's fine. Or you just want to stick with the old way of putting the data type, that's fine. Everybody okay? So it works for all the different data types. Scope is something that we're going to keep talking about in this class. Basically, what it means is you can't add 2 variables together if you don't know the values of the 2 variables. So it's important when you're writing your program that you declare your variables first and you initialize them, and then you use them, you know, whether that means adding them together, doing some sort of arithmetic, then printing them. So it just makes sense. You can't print something before you've actually declared it. So you have to watch scope. You can't use it before you've talked about it in C++. So the order of not the order of operations, the order of which you write your program is important because you have to, you know, the program has to know about it first before you can do it. So it does go in order. So we call that scope. So example, you can't print out value before you've actually declared value, talked about value. So you just have to move that up and it'd be fine. Okay. So we have different arithmetic operators. So we are going to talk about the third one later when we talk about conditionals. That's how you do a comparison. But, you know, if we're just talking about like a negative number, we can talk about unary or binary, depending on how many. Well, our equations are going to get much longer. This chapter is pretty simple because we're just focusing on simple 2-number equations. So we didn't even talk about like order operations or anything like that, but you'll probably remember order of operations from math, right? Parentheses first and then. Good job. Yeah. Okay. So these are different types of symbols we can use. You'll know what the first 4 are. The only new one that you have to add to your list is modulus. That means remainder. So it's pretty cool because whenever you're trying to divide something, if you want to know how much is left, so if you did the exercise, you had to find out if you were converting inches to feet, right? How many inches would be left over? So you say, okay, I have 13 inches, but you only need 12 inches to make a foot. So how many would be left? And we know in our head that's 1, right? But we need the computer to be able to calculate that. So what you could do is you can actually take the 13 inches that you have and divide by 12, and it should say 1. And we'll talk about this in just a second. And then you can take the 13 modulus 12, and it should give you a remainder of 1 as well. So I should have did a different example there. They both weren't 1. So let's say we had 14 inches. Then we would get 1 foot and 2 inches left over, right? So the modulus part would be 2. So when we do division, you have to be careful of this. If we have 2 integers, which means we have 2 whole numbers, you're actually going to get an integer answer. Okay. And so we only have to worry about this with division. When you're dividing 2 numbers, if both of them are integers, both whole numbers, you get a whole number answer. So it's very strange because if you take 1 divided by 4, you would actually get 0. No, it's 0.25. Well, yes, it would be normally, but it wouldn't be if you took 1 and 4 and they were both whole numbers. So if you just make one of those a decimal number, like 1.0 divided by 4, you would get the decimal answer of 0.25. Or if you made it 1 divided by 4.0, or both of them decimals, but just one of them has to be a decimal to get the decimal answer. Now, when you're talking about the actual equation, 1 divided by 4, if they're actually like static numbers, like you're typing in 1 over 4, just put a 0.0, like 1.0 in there, and it would make it work. If you're talking about variables, like 1 is a variable and 4 is a variable, and you can change those values, just set the data type at one of those to not be, don't make them both integers, make one of them a double. Okay, and that's how you fix that problem. Now, it's not always a problem, because maybe you want it to say like the feet program that we were talking about, maybe you actually want it to just give you the integer answer. So when you're taking 14, let's say we have 14 inches, we're taking 14 divided by 12. Maybe we just want it to say 1. We don't want it to say the decimal number. And then we would like to do the modulus of 14 modulus 12 to get the 2 that's left over instead of having it be a decimal for the first one. So it just depends on what you're doing. Like if you had a change program and you were trying to give someone change, you don't want your program, wherever you're working, to say, give them 3.2 quarters. You just want it to say 3, right? And you don't want it to round up to the next one. So you don't want rounding. So integer division just means that it's chopping the actual ending off. It's not rounding it, it's just chopping it. So it's just giving you the whole number version of what the answer is. Okay. So there's some examples up there of just some basic things. So 7 divided by 3 is 2, even though it doesn't divide evenly because they're both integers, right? 7 modulus 3 is 1, because if you actually take 3, you basically say how many times is 3 going to 7, 2, and 2 times 3 is 6, and 7 minus 6 is 1, right? So if you're basically doing the longhand division version and taking the remainder. If it's been a long time, let me know if the remainder is kind of hard to figure out. But everybody, so far so good? Okay. All right, so this is just an example. You have all these, it's kind of hard to see up there. You might be able to see it on your screen better, but you just have a bunch of variables with a bunch of different values, and then you have some equations. So it just shows you, like, to calculate the regular wages, you take the base pay rate times the regular hours, and then to get the overtime wages, you take the overtime pay rate times the overtime hours, and then to get the total wages, you add the regular wages and the overtime wages, and then you just print it off. So it's just trying to show you as an example how you can do the equations and save in different variables and how you can print that off. So just, I think the more examples, the better that you see. So I like that your book has a bunch of different examples. Okay. So if you want to print off the answer, you don't necessarily have to put in the variable. You could just put it in a cout, and it will just give you the answer in the cout. So 13 divided by 5, remember, is 2 because it's integer division. If you want the decimal, you have to say like 13.0 or 5.0 to get the decimal answer. 91 divided by 7 actually is 13. So if you want, down below, if you look, see how it says 13 divided by 5.0, you get 2.6. You just make one of them. It doesn't have to be the second one. It could be the first one too, or both. And then the second one just made the first one a decimal, and you get the decimal, but it just so happens that those two numbers divide evenly, so there is no decimal. Okay, everybody okay? All right. Are you guys okay on Zoom? Am I going too fast? Okay. So modulus 13 modulus 5, just some practice. You're going to want to use integers for that, not doubles. So 13 modulus 5. So you say, how many times does 5 go into 13? Well, it goes in 2, and then if you multiply them, you get 10, and 13 minus 10 is 3, right? Everybody okay with that? Okay, all right. And we already talked about comments. I am not super strict about comments, but I do want you to have them at the top of your program. Just like when you turn in a paper for your other classes, you always put your name and your date and everything at the top. Just get in the habit in your exercises and your assignment of putting your name and your date, and just a simple explanation of what the program does. It doesn't have to be like a paragraph, just like a one-line thing on what it says. You know, it's just good practice. If you want to comment throughout your code to tell yourself what it does, that's great. You don't have to do that, especially at this level, because most of the time it's pretty obvious what it does. If you're, adding two numbers together, you don't have to put I'm adding these two numbers, if you were to have more complicated code, then it might be nice to explain to somebody what's going on. If they're looking at code, you did it in a unique way. It's great to have comments. It's good for you if you want to go back and use this reference, but I'm not requiring you to put it throughout. But when you get to the next class, they might have different requirements. So, okay, so just like in here, see how they're putting comments at the end of the line to say length in inches. It's really not necessary. If you want to write it in there, you can. Anytime you want to make a little note to yourself, just put a / and whatever you want to say about that line is fine. It doesn't bother me if you want to do that on your code. It is nice sometimes to put like calculation. Sometimes I'll put like input, calculation, output or something for comments, just so you know. These are like the different sections, but it's not required. Okay. Multi-line comments are nice because it's a little less typing, right? But it's also nice if a section of your code isn't working. Instead of going to every line of your code and doing / before it, you can say, okay, this little block of code's not working, but I don't want to delete it because I worked really hard on it. But I'm going to leave it in there. But if you leave it in there, you get errors, right? So you could go to every line and go ////. But you can just start at the beginning, /*, ignore that temporarily, come back and take that off when you're ready to play around with it. But that just makes the compiler ignore it for now because it's causing problems. And then later put it back in there because you don't want to delete it because you might want it later. Or like maybe you have it 2 different ways and you want to show me the second way, you comment out that second way or something like that. Okay. Sometimes we have variables that are called constants that don't change. So like pi, for example, a dozen things that don't change, maybe like a tax rate. You put them as constants and then those values don't change. So you just put CONST and that means constant and it doesn't change. Okay. So same as before. Now you do typically capitalize the variable name in all capital letters and use an underscore because you can't see the difference between the 2 words, like tax rate. If you did that, it's hard to read. Although I see people are getting more used to it now with the hashtag. People can separate the words better. Sometimes I still have to look at that a couple times. You can put an underscore between the words so you can tell the difference, but capitalize them so people know it's a constant when you use it in your program. Okay. So you can see this example. They have pi, and then you have the diameter, and neither one of those is going to change. So then you have the output. It's the same, except you just put constant at the top and capitalize the variable name. Okay. Some professors are really picky about how many enters you hit between this block of code and this. Whether you do things on 1 line or 2 lines, and whether you use end L for end line or you use /n, that doesn't really matter to me. I'm not real picky about that. So unless it's like a really inefficient way of doing something, then I might talk to you about it. But otherwise, you're going to see that everybody has a different style of programming and things are going to make sense to different people different ways. And they're going to have a preference on, how you do things and what makes more sense to you. So you're going to start to see that everybody does things differently. You might do an assignment one way, somebody else might do it. That's why sometimes it's a little, when I get things that are done exactly the same way, I start to question if 2 students have exactly, when we get far enough along, then I start to wonder if somebody worked together, because it's hard when you get enough code. It's hard. 2 people aren't going to write the code exactly the same. At the beginning, there really isn't a whole lot of different ways to put hello world. Okay. But when you start talking about loops and conditionals and arrays, everybody thinks differently. So people are going to name their things different. They're going to make it look different. And that's fine. That's good. So that's why I want to remind everyone that we have a tutor for this class. His name is Matt. And although he's located at Spring Creek campus, which I know is not real convenient for here, he might have a different way of describing things. So if you come to me for help and it's still not making sense, I can try. You can come to me again and I can try and explain it a different way. But because we all have different ways of explaining things, sometimes just a visit to see Matt might make it make sense because he has a different way of thinking about it. And so sometimes when students come to me from seeing him, I'm like, oh, that's a unique way of explaining it. I never really thought of it like that. So he has some hours at Spring Creek and also online on Fridays. So if you're ever over at the Plano campus and you want to stop in and see him if you have a question, yeah, feel free to see myself and him, but it's just good to get different opinions. Now, you don't want to ask students in the class because a couple reasons. They might not really know what they're doing. They might say that they do, but they might not. It might make you more confused. But also they might not know how to explain it in a way that will help you in the future. And so you might still be lost. And so make sure you come to myself or Matt if you need some help instead of going to other students in the class. But that's kind of the end of that. Anybody have any questions? Okay, so I do have, I have two chats. Oh, you're good. Okay, good. I have a little game I want to play with you. Have you all played something called Kahoot before?
Yes.
Cool. Okay, so you're gonna go to Kahoot it, Kahoot it, and I'll get you the code in just a second. It'll come up. Make sure I show it on your screen. I know there's this, okay. I can show the questions on your screen. Okay, so it's going to load a game pin. So if you just go to Kahoot it, www.kahootit, and type in 583456, you can make up any nickname you want so people don't know who you are. If you know, I just don't want you to feel uncomfortable answering the questions, so people won't know if you answer correct or incorrect. All right. We're gonna get started, but if you haven't finished, that's okay. You can still join. Down at the bottom will be the game pin. So what'll happen is it'll ask a question and it'll have you just click on what answer you think it is, and then it'll give you a certain time, and then it'll kind of stop, and then we'll take a look at it. Make sure that everything's making sense. Hey guys. I actually think I messed up my spacing here. Sorry about that, guys. But because that wasn't an option, y'all knew what I meant by that.
I know.
I was just looking at it and I was like, okay. So I'm like, that's not quite right. All right, so I wanted you to know that there's actually going to be quotes in your actual output, just because you have quotes on there. If you want quotes in your output, by the way, you just put a /quote, double quote, and it'll actually appear as a quote, because you can't put like quotes if you want a quote, because it thinks you want to start and end your string. So you have to put /quote to actually get a quote. So the problem with the choices that I have is that there's no space here, and then there's no space here. So there actually wouldn't be a space here and here, because I didn't put a space here. So, but it doesn't print on separate lines because it doesn't have any end lines or /ends in there. So I wanted you to know that it didn't do separate lines and it doesn't put the quote. So this is the only option that's sort of right, but not quite the best option with what we have. So I'll have to fix that later, but actually would make all the words one giant word, but take out all the spaces. Sorry about that. So I need to either fix the spacing in here or the spacing in here, but y'all got the idea, right? Sorry about that.
Mistapped.
It's okay. All right.
Too much time looking at it.
So if you remove the quotes, that would be right. But if you have the quotes on there, then it actually registers as the word total instead of printing what's in total. So just be careful that you don't have quotes around your variable names. That makes sense, Jordan?
So you can hear the space last time, so I got really confused when they were back.
Yeah, I actually did it right this time.
Yeah, I was like,
Sorry. Even when I think I know what I'm doing, I should double check it right. All right, good job, guys. So just an integer division rule, just to make sure you actually aren't taking the decimal with that one because they're both integers. So just, it doesn't matter what the leftover part is. If you made one of those a decimal, you get a different answer. Okay, good job, guys. So you just have to get the remainder. So if you take 18 divided by 7, 7 goes into 18 twice. And then you just take 18 minus 14 and you get 4, right? Are you okay with that? I know that's a new one. Okay, good job. So you just can't do it backwards like that. All right, any questions on any of that? Okay, I didn't have as much to ask in this one. We'll try to have more questions on the next chapters, but because you didn't really do advanced equations, I couldn't have that yet. We'll have that in the next one. So what I want to do though is with the remainder of the time, we have some time left. I want to make sure it's making sense. And so I want to, you can work together or you can work with a partner. I want to have you work on a simple program, or if you just get into the online GDB, and I want you to try to have a conversion from minutes to hours. Okay, so you can do it one of two ways. You can do it where you have, okay, we have 90 minutes. We can say, the decimal number for how many hours that would be. Okay, so we would have 1.5 hours, right? Or we can have the remainder and say that that's, 1 hour and, 30 minutes left, right? Because it doesn't need power. So you can do it either of those two ways. So just simple equations, right? So you would need to have a variable at the top for minutes, and then a variable that has your hours, that has your calculation, just divide by 60, and then just print it off. So real simple. So you can do it individually, or you can do it with a partner if you want. You can just do it on online GDB. If you're on Zoom, I'm going to go ahead and put you in a breakout room just so you can work with each other if you want to, or you can do it on your own. That's fine too. And then I'm just going to make sure that everyone's okay with that. And just quickly before we do that, though,
Wait, we still have one more question.
we have another question.
Yeah.
Did I? Oh, sorry. But oops. I think. Oh, I'm sorry. One more question. I thought I was done. Sorry, guys. One more question, and then we'll do our breakout. Okay, good. So int, because it's a whole number, because I never heard anyone answer a decimal answer for their age. And char wouldn't work because it would, if you had more than one digit, it wouldn't work. So it should be int. And then I can show you the scores too, because I know some people are interested in that. We'll finish off Kahoot. And then we'll go back to the challenge that you have to do. Okay, so what we're gonna do is go back here just to make sure everybody's with me, what you have to do, and then we'll do the little activity that I was talking about. So when you go to the discussion board, you know you have to do part 2, right? So part 1 is just coming up with some basic things like name, Bob, and then somebody else has to come along and say that that's a string and actually declare it and initialize it. So if you have any questions about that, let me know. Your assignment directions are listed here. So hopefully pretty easy. Let me show this Kahoot off. Okay. So for the assignment directions, it's pretty simple. You're just make sure you put your comments at the top, and then you have a variable with the number of kilometers. Then you're going to initialize it at 5, and then you're going to do your equation where you convert kilometers come out. So 1 kilometer is equal to 0.62137. Then save that in miles and then display your answers. So you can see the example. So pretty easy, right? Okay, so I just want to make sure everyone's okay with what you have to do there. You have to do that by Sunday. And so if you didn't do your exercise, you didn't finish your discussion, you have your assignment. This is pretty simple. Hopefully this is just some basic calculations that you have to do. And when you actually answer them, you can just type them right into the text box. So it's nice and easy for me, because if you put them in Word, then I have to load up Word and everything. But if you just type them right into the text box when you submit it, you can just do these basic questions, hopefully pretty easy. And then your quiz you'll take by Sunday, whenever you're ready. Okay, and then also starting chapter 3. Does that make sense, everybody? Okay, so back to the breakout session I was talking about before. So what you're doing is you are just doing this simple thing just to make sure everybody is with me. And if you can do this, then it hopefully makes sense. So what you're going to do is you're going to convert minutes to hours. And you can do that again with what's left over. You can just do it as a decimal number, whatever is, whatever you think is more interesting. So basically, you're going to declare your minutes and hours variables to decide what data types those should be. And then do your calculation, just divide by 60 to get the hours, right? And then just do your output for the answers, right? So you don't have to take an input from these or anything like that, because we haven't talked about that yet. So just have your minutes variable and put a number in it, any number for testing purposes, and run it. And then you can put a different number in it for testing and run it again to see if it works. You can work with a partner or you can work by yourself, but just let me know if you get done. I could take a look, and then if it makes sense, you're all good. And I also have to mark you all done for attendance today. So while you're working on that, I'll go through attendance. And are you guys okay on Zoom? I'm going to go ahead and split you into a group and take a screenshot, make sure I mark you down for attendance.